on x cubed minus 2x squared minus 4. We divide it by x plus 1. I've got my negative 1 out here. I have my coefficients on the inside. I've added the 0 for the 0x. I get a remainder of negative 7. Okay. If I take this negative 1 and I plug it into the polynomial, this is my a value. Okay. Remember, this is x minus a. That's like x minus negative 1. So your a value is negative 1. And I plug it into the polynomial. What's negative 1 cubed? Negative 1. Negative 1 squared is 1 times negative 2 is negative 2 minus 4. Negative 1 minus 2 minus 4 is negative 7. Okay. If you plug the a value into the polynomial, you get the remainder. All right? There's a mini proof. I'm not going to do the next one. There's a mini proof at the bottom here. We can just go through it quickly. We write everything as p is equal to dq plus r. Well, our d is our divisor, which we know is x minus a, right? So I can rewrite it like this. Now, if I put a in there, anything in brackets goes in where? What variable? In for x. So we're going for that x. So you end up with a minus a, which is 0. 0 times the quotient is 0. So you end up with 0 plus r. So that means p of a equals the remainder. In other words, if you put the a value into the polynomial you're dividing, you get the remainder out. And you're like, well, why do you need to know the remainder? We're going to learn that. Okay, but we're going to practice this first. So if we flip the page, this is called the remainder theorem, by the way. If you want to know what the remainder is, just plug the a value in. So use the remainder theorem to find the remainder when, here's our polynomial, is divided by x plus 1. So what is my a value for x plus 1? Negative 1 is what makes it 0. If I put that into the polynomial, always bracket when you sub it in because the signs are important. I'm going to get negative 6 minus 4 minus 8 plus 6. Negative 6 cancel. Negative 12. That is your remainder. If you did synthetic division or long division on that polynomial, your remainder would be negative 12. Okay. Okay, what if I divide by 2x minus 1? What is my a value of that? 1 over 2, 1/2. So you can think of it like this, like we did before. You can factor it out. You don't have to. You can just look at it and go, oh, my a value is 1/2. So now you're all going to hate me because it's got fractions. We're going to test our fraction skills here. All right. No calculator. What's 1/2 cubed as a fraction? 1/8. Right? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So it's 6 times an 8 minus, what's a half squared? 1/4 or a quarter plus 8 times a half is 4 plus 6. Six times an 8 is 6 times an 8th is 6 over 8. What's 4 times a quarter? Negative 1 in this case because it's negative 4 plus 4 plus 6. 10, that's minus 9. Yeah, totally. So plus 9, 6/8 plus 9. How do you add fractions? Common bottom or common denominator, but same thing. So we got to make the denominator on the 9 and 8. So that means you multiply top and bottom by 8, right? It's 9 times 8. Yeah. So 9 is the same as 72 over 8. Then you can add the tops. 78 over 8, which reduces to 39 over 4. Don't worry, I won't ask you that on a test, okay? I just wanted to do that because it's fun. So that is your remainder, 39 over 4. R. All right, one last question before it'll bring us up to break. Find A. It's really unfortunate they keep using the letter A. Let's just call it B and make that unknown B. Just use A's everywhere, which is fine, but find B if the remainder is 131 when the polynomial 2x to the fourth minus x cubed minus bx plus 8 is divided by x minus 3. Okay. They've told us that what the remainder is, right? And when you put the a value into the polynomial, it spits out the remainder. So what is the a value of this? Sorry? What's the a value of x minus 3? What makes it 0? 3. That's your a value. Okay. If I put that into the polynomial, so I go p of 3, I get 2 times 3 to the 4 cubed minus b times 3 plus 8. That should give me the remainder, right? Everybody agree with that? If you put your a value, you get the remainder. What is the remainder? They've told us it's 131. So now it's just an algebra problem. 3 to the fourth is 81. 3 cubed is 27. $162.
Good morning, Royal Bay. I hope you're having a wonderful Wednesday. It's me, Rory, for your morning announcement.
If you do all that algebra, you get b is equal to 4.
Are you interested in trades? The task program is a hands-on trades program. It exposes students to various construction and mechanical trades as they explore units in carpentry, electrical, plumbing, and metal trades. Applications for semester 2 are available in the Career Center.
1 and 13A, please. So, if we have polynomial x squared plus 2x minus 24, and we divide it by x minus 4, okay? We do synthetic division on that. I've got a 4 on the outside. That's my a value. I don't have to add in any zeros. I dropped in the 1, 4, 6, 24. I get 0. My remainder. So if I asked you to write it as dq plus r, my divisor is x minus 4. What's my quotient? If we divide a quadratic by a linear, I should get a linear. So 1 and 6, it becomes x plus 6. And my remainder is 0, which you would never write like that. But let's just say we did that. What have I just done? You did over and over again in grade 11. You just factored it. Okay. So if the remainder is 0, then x minus a is a factor of the polynomial. These are called factors. Okay, this is called the factor theorem. If your remainder is 0, then whatever that a value is, or x minus a, is a factor of that polynomial. And that's why we do this, okay, in grade 12. We want to factor polynomials. Because when you factor polynomials, you can get x-intercepts and all that kind of stuff when you're graphing, which is what we're going to do. All right, so that's the key thing. Factor theorem. I'm not going to ask you what the factor theorem is. All you have to remember is if, let's just write it. If r equals 0, then x minus a is a factor. That's what you need to remember. Okay? That is the key take-home point from that page. We're not doing any questions on that page. We're going to use it in the next lesson, lesson number 5. Okay? So we're going to scoot down, or we're going to go to page, what page is this? Lesson 5 on page 413. Okay, this should be a bit of a review from grade 12 or grade 11. So we got a quadratic function here, a parabola. If you look at the graph, it has x-intercepts at 3 and -2. If you factor it, it turns into x plus 2, x minus 3. And then when you find what makes each bracket 0, those are called zeros. Surprise, surprise. You get 3 and -2. And if you solve the equation where it equals 0, basically gives you 3 and -2. Those are called roots. Remember from grade 11, roots, x-intercepts, and zeros are all the same thing. Same number anyway. Okay. Don't worry about that. Okay. A regular quadratic, if we factor that, we get x plus 8 and x minus 3, right? Because we're looking at what multiplies to the -24 and adds to the middle. And 8 and -3 multiplied -24. If we look at a cubic, here's our cubic function. The factors of this cubic function are x minus 2, x minus 1, x plus 1. If I multiply -2, -1, and 1, what do I get? It's -2 times -1. Positive 2 times 1 is 2. That is the constant term. Same as when you're doing quadratics. 8 and -3 give you -24. So if you multiply these zeros, i.e. what makes each of these 0. So let's say, I'm just going to rewrite this. Zeros are factors of the constant term in any polynomial. Okay? i.e. I'm not going to say what the first factor is. Like, if you're factoring something, you got to start somewhere. So what you do, you look at the constant term and you say, what are the factors of that term? And if it was a quadratic, like you did in grade 11, factors of this I mean, it could be what you're actually doing is you're going 2 and 12, right? That multiplies to 24. 8 and 3 multiplies to 24. 24 and 1 multiplies to 24. 6 and 4 multiplied to 24. And then you go, in your head, you go, well, which of those pairs would add to this? Okay, that's what you're doing. That's a little trickier when it's a cubic, but we can still look at all the factors of the term there. Okay, and that's what we're going to do on the next page. So flip the page, please. Okay, so we have a polynomial, x cubed minus 7x minus 6. List the potential zeros. Forget all this stuff. List the potential zeros. When they say list the potential zeros, they're essentially asking for the factors of the constant term. So just look at 6. What are all the factors of 6? What multiplies to 6? 6 and 1. I'll list them over here. 6 and 1. What else? 2 and 3. Now, you could have -1 and +6 to get -6, right? Or you could have -6 and +1. Or you could have -2 and +3, or +2 and -3. So when they ask for the potential zeros, it's actually easier if you just go ±1, ±2, ±3, +-6. You don't have to write +1 and then +2, -2. If you just put plus minus, I'm happy. So those are the potential zeros. The potential factors are when you write them in brackets. So you could go x plus 1, x minus 1. That's going to give you the factors of 1 and -1, or the zeros of 1 and -1, sorry. Right? And then you could do it for everyone, x plus 2, x minus 2, x plus 3, x minus 3, x plus 6, x minus 6. Those are the potential factors. Instead of writing them all out individually, though, I will be fine on a test if you just write x plus minus 1, x minus 2, x plus minus 6, and x plus minus 3. Okay, just to save yourself a little time. That's all I need you to do. How do you know which one of those would be a factor? Is the correct factor, the one to start with? How do you know if something is a factor? We just did it. What does the factor theorem say? If the remainder is 0. If the remainder is 0, then it's a factor. So what you would do is you would, in reality, you would test each one of these by plugging it into the polynomial and seeing which one gave you 0. And the one that gave you 0 is the one you would start with, the factor. Okay? I'm not going to make you test every single one because that would be tedious, to say the least. So I will narrow them down. So if we skip to the next page, we're going to factor this polynomial. It's a fourth-degree polynomial. There's no way you guys know how to factor this. Right? In fact, there's no I think there might be a formula for fourth degrees. Like there's a quadratic formula which will factor all second degree polynomials. There's a cubic one. I think there's a fourth degree one. I can't remember. But once you go beyond 4, there is no formula. So you have to do this kind of stuff. Reality is a computer would do it. So you guys are computers for now. Okay. First step is potential zeros. So you just look at constant term. What are all the factors of 12? Everything that multiplies to 12. What are they? Start with the easy one. 1 and 12. So plus minus 1 plus minus 2, plus minus 3, plus minus 6, plus minus 12. I missed 4, didn't I? Plus minus 4. There we go. Those are the potential zeros. If I ask you for the potential factors, then you would say x plus minus 1, x plus minus 2, x plus minus 3, 4, 6, and 12. Okay. All right. Which one should we start with? There's actually 12 of them there. I'm not going to make you test all 12. What I will do on a test is I'll ask you to list them all, but then I'll say, using these 3, tell me which one is a factor. Okay? How do you know if something's a factor? The remainder is 0. Okay. I'm just going to tell you which one to use right now. Check the factor x minus 1. Okay? So if r equals 0, it's a factor. So we have to find out if r is equal to 0. Okay? So we have a couple ways to do this. We can put the a value into the polynomial. What's our a value if our factor is x minus 1? Positive 1. So I can go p of 1 is equal to 1 to the 4th plus 2 times 1 cubed minus 7 times 1 squared minus 8 times 1 plus 12. Which is going to be 1 plus 2 minus 7 minus 8 plus 12. And if you do all that, you're going to get 0. Everybody agree with that? All right. So if it's 0, therefore x minus 1 is a factor, which is good for us. Because then what you do is you do synthetic division. Okay? So divide by x minus 1. So 1 goes on the outside. Do I have to add in any zeros for our polynomial? Do the exponents go down in order? Yes, they do. So 1, 2, negative 7, negative 8, 12. And then just do synthetic division. And we get a remainder of 0, which confirms what we did over here. And we write everything how? How do I always want you to write stuff in grade 12? dq plus r. That's how we write everything. So our divisor was x minus 1. The quotient, what is the quotient? Remember, we're starting with a 4th degree. So it should be a x cubed. So the quotient is going to be x cubed plus 3x squared minus 4x minus 12 plus the remainder, but the remainder is 0, so that makes us happy, right? Okay. Why is this question not fun? Do you know how to factor a cubic? So what do you have to do? Do it again. Right? So I won't ask you this on a test because this could get really tedious. But you would look at the factors of this. Okay? Which it turns out are the same as the ones we used before. Okay? So I'm just going to say try x minus 2 because I know that works. So then we do synthetic division. Again, so 2 goes on the outside, and we're just doing it on this polynomial here. So it's 1, 3, -4, -12. And you do it again. So we have 1, 2, 6. Get a remainder of 0, which makes us happy because that means it's a factor. Write it as dq plus r, but don't forget the x minus 1 still is there. So it's x minus 1 times x minus 2 times, what's our quotient? We're dividing a cubic by a linear. So our quotient should be a quadratic. So x squared plus 5x plus 6. Remainder is 0. Now we're happy because why? Do you know how to factor a quadratic? What multiplies 6 and adds 5? 2 and 3. So then it becomes x minus 1, x minus 2, x plus 2, x minus 3. And that is the factored form of that polynomial. Okay? I'm not going to ask you a 4th degree on a test, or a 5th or a 6th degree, because you would have to do it again and again and again and again. Basically, your whole goal is to get it so that you have a quadratic here, because you know how to factor quadratics. Okay? So, first step is to look at your constant term, write out all the factors of that constant term, pick one to try. I will narrow it down on the test for you. I'll narrow it down to 3 choices. I will ask you to list them all. That'll be worth a mark. Then I'll say using these 3, completely factor the polynomial. And so you have to test to figure out which one is remainder of 0. Divide it by that factor. Take, if it's a cubic, you're going to have to do it again. Right? If it turns into a quadratic, then you just factor, like you always have. Okay? All right.